Intrinsic and Extrinsic Semiconductors. Intrinsic semiconductors. Imagine a material like silicon, which has 4 electrons in its outer shell, valence electrons. These electrons are tightly bound to the silicon atoms, so they don't move around freely. This means that silicon is an insulator, which means it doesn't conduct electricity very well. Intrinsic semiconductor. However, if we heat up silicon, some of the electrons will gain enough energy to break free from their atoms and become mobile. These mobile electrons are called conduction electrons. At the same time, the silicon atoms that lost electrons are now left with a positive charge, which are called holes. Holes can also conduct electricity, but in the opposite direction of electrons. So, as you heat up silicon, the number of conduction electrons and holes increases, and so does the conductivity of the silicon. This is why semiconductors are sometimes called temperature-dependent conductors. Extrinsic semiconductors. Now, if we add a small amount of impurity to silicon, we can control its conductivity even more. This process is called doping. There are 2 main types of doping. N-type doping. This involves adding an impurity that has 5 valence electrons, such as phosphorus. When phosphorus is added to silicon, the extra electron is free to move around and act as a conduction electron. This creates an excess of negative charge carriers, so silicon doped with phosphorus is called an N-type semiconductor. P-type doping. This involves adding an impurity that has 3 valence electrons, such as boron. When boron is added to silicon, it creates a hole because it's missing an electron. This creates an excess of positive charge carriers, so silicon doped with boron is called a p-type semiconductor. Doping is a very important process in the semiconductor industry because it allows us to control the electrical properties of semiconductors, which is essential for making electronic devices. Here is a table summarizing the key differences between intrinsic and extrinsic semiconductors. Feature: intrinsic semiconductor, extrinsic semiconductor. Purity: pure doped with impurities. Conductivity: low high. Charge carriers: equal number of electrons and holes, excess of either electrons or holes. Examples: silicon, germanium, N-type silicon, P-type silicon.